Welcome to part 3 of the Overview of Patterns module. In the previous modules, parts of this module, we discussed the importance of design experience and leveraging common design structure and behavior to become a master software developer. We also introduced the concept of patterns as a means of improving software developer productivity and software quality, and described some of the common characteristics of patterns. In this part, we're going to provide an overview of a variation-oriented process for successfully applying patterns to software development. In order to apply patterns successfully, there's a number of things that developers need to do. First and foremost, it's important to get broad knowledge of patterns within particular domains. Now, this is an interesting topic because it often turns out that when we are first exposed to a pattern and we first learn about its structure, its functionality, the common roles and relationships, the consequences, and so on, we tend to think that it applies to the domain in which the description was originally provided. But sometimes, and often is the case, that there's more to the pattern and more to the applicability of the pattern than the design domain in which it was first published. So to give you a nice example of this, let me give you some background from my experience as I was learning patterns in the early 90s. Around 1993, I became a reviewer for what was to become the classic Gang of Four book, the Design Patterns Elements of Reusable Object-Oriented Software book. And what was interesting to me is I was reviewing the patterns in that book, which had really never been published much before. Certainly I had never seen them before. I was also in the process of learning about distributed object computing middleware, in particular something called the Common Object Request Broker Architecture, or CORBA. And what was fascinating to me was even though the distributed object computing middleware domain appeared at face value to be quite different from the domain that many of the Gang of Four patterns were described in, namely the domain of graphical user interfaces, many of the patterns I was reading about in the Gang of Four draft were showing up in the CORBA implementation I was working with. So for example, CORBA had proxies to be able to interact from clients to potentially remote objects. They have adapters, things of being able to take incoming messages and turn them back into method calls on remote object implementations. They used facades to be able to shield the details of the underlying operating system and the underlying middleware, the complexities in those frameworks. They had bridges to manage memory. And the particular implementation of CORBA I was looking at also used the Gang of Four chain of responsibility pattern for various kinds of filtering and threading and other kinds of adaptive behavior. So that really taught me several things. It taught me, first of all, that patterns were a powerful concept and smart people in different domains had independently discovered the same patterns, which demonstrated the generality. And it also taught me that what might appear at first glance to be a domain-oriented pattern very often has a broader range of applicability. Now, back in 1993, there weren't that many places to go to learn about patterns. There was some papers that the Gang of Four had published at the eCoop conference and just a little bit of stuff that was around at that time. If you could read German, you could have read Eric Gamma's PhD dissertation to learn about some of the patterns he identified in ET++. If you were a C++ programmer, you probably would have learned about some of the C++ idioms from Jim Coplein's book on C++ idioms, but there wasn't much else to go to learn about patterns in different domains. Nowadays, flash forward 20+ years, there are many, many books, there are many, many pieces of web information, papers, etc., for you to learn all about patterns. So it becomes much easier, at least in theory, to have broader knowledge of patterns in a wide variety of domains, some of which are very specialized, some of which are more generalized. So that's part one, learning what's out there. I'll never forget, I went to a conference 15 years ago, and the speaker asked the audience, how many people here have heard of patterns? And almost everybody raised their hand. He said, how many people here have bought the Gang of Four book? And I'd say about 2/3 of the people raised their hand. He said, how many people out there have read the Gang of Four book? And maybe about half the people raised their hand. And he said, how many people out there understand the visitor pattern? And maybe 3 people raised their hand. Visitor is one of the more complex patterns in the Gang of Four book. The point there is that it doesn't do much good to have a body of literature on patterns if people don't take the time to learn it. So that's the key starting point, is to get to know what's out there that's important to you. The next thing, once you have a good sense of what the field of applicability of the patterns are, is to evaluate the trade-offs and the impact of applying certain patterns in your software. And this is a really crucial step, and it's something, again, that comes with practice, it comes with repetition, it comes with team support, it comes from self-study. We'll talk a bit about that, how you might set that up in your own organization in just a second. Let me give you a simple example from my ill-fated attempts at trying to develop the design of my gperf, perfect hash function generator program. I think I mentioned earlier that I'd hard-coded myself into a corner by using lots of if-else statements and using lots of other things that were difficult to change, and therefore as I got requests to add new features, and as I wanted to port my software generator to new languages to generate perfect hash function generators for languages beyond C++ and C and so on, I was having a hard time doing that. Now, a couple years after that point, I learned about patterns. I reviewed the Gang of Four book. I really became excited and interested in this particular line of thinking. And so, in retrospect, armed with the knowledge of those patterns, I could go back and refactor gperf to make it better. And that leads to the next point. It turns out, if you read the Gang of Four book carefully, that there's a number of different ways of trying to make your algorithms more flexible and more pluggable. In fact, there's a couple of different patterns that you could look at, one of which is called template method, and the other of which is called strategy. And they're both trying to do roughly the same sorts of things. They're both trying to make it possible to have an algorithm with some fixed set of steps, and then be able to selectively vary some of those steps or all of those steps in order to have the algorithm do slightly different things. So for example, in my gperf example, I could have used either of these patterns in order to be able to parameterize the way in which I was generating code for the different languages. Or I could have come up with a way of generalizing certain aspects of the perfect hash function generation process itself, the part that was actually computing the perfect hash function. Or I could have had different pluggable data structures that might have worked better or worse under different circumstances of the input keyword sets, etc. Well, when I have to make this design decision, I have to first know that these patterns exist. And once I know the patterns exist, I have to know what the trade-offs are between the patterns. So, for example, the template method pattern works by defining a base class with something called a template method. And the template method is a fixed set of steps where some of the steps are performed by things called primitive operations or hook methods. And these hook methods are virtual, and so some other developer could come along later, subclass from the base class of the template method, and then be able to selectively vary the substeps by changing the way in which the hook methods behave. So the basic idea there is you subclass from the template method base class and override some of the virtual methods, the hook methods, in order to change certain selected aspects of the algorithm in a controlled way. And that requires the use of inheritance to work properly. The strategy pattern can be used in much the same way. You can have an algorithm with certain steps, but rather than using inheritance per se, what you typically do with strategy is you parameterize some black box base object with various strategy objects. And you can do this parameterization through parameterized types, more at early binding at design and instantiation time, or you can also do it with various kinds of dynamically bound objects which you can connect at runtime and so on. But the point is that you let the algorithm make call-outs to these various strategy objects, and then people can come along and plug in different strategies in a selective way. So strategy is more about object composition. Template method is more about subclassing and overriding. And of course, there are trade-offs between those approaches. The strategy approach is more of a black box approach, which means it's a bit easier to use but somewhat more complicated to develop because you have to think through more of the interfaces more carefully. It's more black box. In contrast, template method is more white box. It's easier to implement because you as a developer don't have to think through up front as many of the interfaces and interactions, but it requires more work on the part of people who have to subclass perhaps many different subclasses to provide all the different combinations of variations with that particular approach. So the point here isn't to say that template method is better than strategy or vice versa. It's to say that an architect applying patterns has to be able to navigate through the design space of patterns, knowing how to choose different approaches appropriately given the constraints in which they work. Once you've figured out which patterns you want to use and determine their trade-offs more abstractly, now it's time to get serious and figure out how you're actually going to go about implementing the software using the patterns that you've selected. And this is where things get quite interesting, because it turns out that patterns may need to be modified or tweaked based on the particular context in which they're being applied. And we're going to take a look at a couple of different ways that this might occur in practice. Let's go back and use our observer pattern for a moment. So we all saw the observer pattern before. You've got a subject and an observer, and the observer is an abstract class, and you subclass from it to provide concrete observers. And in the canonical gang of four observer description, you'll have method names like attach, detach, notify, and update. But now let's see what might happen if we start playing around with Android and the various frameworks in Android. Well, the first thing that you discover is that there's observers all over the place, but they don't look quite like the ones you find in the Gang of Four book in certain ways. The variations are very minor, but they're not going to be one-for-one compatible in every aspect, and that's perfectly okay. Patterns don't have to be exact in order to be the same pattern and in order to be useful. For example, one of the ways that the observer pattern is used in Android comes when you implement things called content providers and content resolvers. And they allow you to be able to set a content observer which can be called back when content in some kind of database, like an SQLite database or a file or some other form of persistent storage, happens to change. So in this case, you're not inheriting from observer, you're inheriting from content observer. You're not overriding the update method, you're overriding the onChange method. And you're not calling notify, you're calling notify change on something called a content observable. Again, admittedly, relatively minor changes, but not quite exactly the same that's in the Gang of Four book description. This particular diagram also illustrates the use of UML notation to illustrate how the particular classes or roles in a concrete design match back to the various roles and responsibilities defined in a pattern. You can see here that the content observable is part of the observer pattern, and it's playing the subject role. Likewise, the content observer is playing the observer role in the observer pattern. So this is a nice way of being able to annotate your UML diagrams to show not just the what and the how, but also the why. In other words, why are we designing it like this? Because we're trying to implement part of the observer pattern. If you poke around a bit further in Android, you'll find other uses of the observer pattern. For example, Android has a very powerful framework called the Intents framework, and it's used to be able to connect together various components in a late binding-like fashion. And we'll talk more about this later in the course. One of the key things that's used to glue those components together in Android is something called broadcast receivers. This again is an example, a realization of the observer pattern. But now we have something called a broadcast receiver with an onReceive hook method. We have something called a context with methods like register receiver, onRegister receiver, send broadcast, send ordered broadcast, and so on. And this is how we notify the various broadcast receivers when some event occurs that may be of interest to them. So this is a different use of the observer pattern. In fact, this particular use of the observer pattern actually gets a bit closer to a related pattern that appears in the POSA 1 book called publisher-subscriber. And we'll talk about that a little bit later. The reason why it's a little bit closer to publisher-subscriber is because one of the key features you get with Android's intense framework is the ability to have filters. So only certain broadcast receivers get notified when broadcasts are sent out. There's some other more sophisticated examples of modifications to patterns that have appeared over the years. Let me walk through a couple related to one of the classic Gang of Four patterns called the Singleton Pattern. The Singleton Pattern defines a global point of access to an object and assures there's only one instance of said object without requiring the use of global variables. Now, when the Gang of Four book was originally published, they described how to implement the Singleton Pattern, which we see here. What you do is you typically put the constructor and make it protected or private, and you have a static method called instance that's public, and people can only access the singleton by calling the static instance method. And what that instance method does is it comes in and it checks to see whether this is the first time that method has been called, and if so, it allocates the one and only instance of the singleton object, stores it in a local data variable, and returns that pointer. Any subsequent time that instance is called, of course, it'll discover the singleton was initialized, and it will return the pointer or reference to that particular object. This is great. There are some issues with singleton that make it problematic for broad-scale reuse, but it's still widely used in many platforms. One of the downsides with the original description of the Singleton Pattern in the Gang of Four book is it didn't talk about how to delete singletons, how to destroy them. It only talked about how to create them. Now, for a lot of the applications that the people had been developing in the Gang of Four author community, things like user interfaces, there wasn't really a need to clean up the singletons. They would simply be shut down when the user interface went away, which might be when the machine was rebooted. So cleaning up singletons was not considered to be important. But over time, as people began to use singleton in other contexts, say embedded systems where you need to unload various pieces of code and you need to clean up the resources, or they leak and you actually run out of memory eventually, it became clear there needed to be a policy for deleting or killing singletons. And so the late John Vlasides, one of the Gang of Four authors, wrote a nice article for C++ Report magazine, which you can find at his website at IBM, called To Kill a Singleton, that talked about some of the ways to delete singletons. So that's an example of a variation to modify the pattern. Going one step further with singleton, when the original Gang of Four authors had developed it, multithreading was not common. User interfaces typically weren't multi-threaded in those days. Very few programming languages and operating environments had support for multi-threading. There wasn't much multi-threaded or multi-core hardware in those days. So as a result, multi-threading wasn't really considered as one of the contexts or forces shaping the patterns described in the book. I discovered this the hard way when I was working in the mid-90s on a project. I was using singleton, and I had a 20 CPU multiprocessor machine. And I was discovering that my programs were crashing in random ways. Well, it turned out there was a problem with singleton. If you look at the classic singleton pattern, if you try to apply it in a multi-threaded environment with multiple threads that can run in parallel, it turns out that multiple threads at the same time can all come in, discover the singleton has not been initialized yet, and they'll all end up calling the constructor and making lots of extra garbage objects, only one of which will be returned. And there's actually other subtleties related to caching and so on that are problematic as well. So the original description of singleton in the Gang of Four book had too little synchronization. Well, my first solution was to basically make the method, the instance method, synchronized, which meant that only one thread at a time would be running an instance. But the problem there was that had too much synchronization. I was locking more than I needed to. And so as a result, my program grew slower, and I was getting pressure from my teammates who said, this pattern stuff is for the birds, let's go back and use a global variable, and then we wouldn't have this problem in the first place. Well, as it turned out, the right solution to this was to actually come up with a new pattern, which is basically a variant or an extension to singleton, although it's a pattern in its own right. And this pattern is called double-check locking, sometimes known as the double-check locking optimization pattern. And basically what this pattern does is it does just the right amount of synchronization. It only synchronizes when the first thread comes in to create the one and only instance of the singleton. And henceforth, all the other accesses are not locked. So you get the benefits of thread safety, and you also get the benefits of not having too much synchronization. Now, it turns out that this was actually added to Java in JDK 5 and above, and it works by changing the memory management semantics of Java threads using special semantics of the volatile keyword. There are also ways of implementing the same pattern in C++ and in C and so on. And if you take a look at the Pattern-Oriented Software Architecture Volume 2 book, this way of doing things is described as one of the patterns there. There's also a nice website at Wikipedia that talks about double-check blocking. And if you go there, you'll find out the history of double-check blocking and some of the issues that arises and so on. So the point to all this is that as the context changes, as the forces change, we may need to rethink the patterns and how to apply them most effectively. The last piece in the puzzle is to actually combine the patterns that you've selected with the implementation techniques that you've chosen with other patterns and then implement and/or integrate them with the actual source code. And of course, this process takes place over time. It's not a simple paint by numbers kind of approach. So I'm going through this and making it sound easier than it really is. But the idea here is that you have to combine the patterns. And it's been my experience building software in a pattern-oriented way for decades now. It's some of the best approaches and solutions I've seen, or the ones I've come up with, are ones that exhibit what's known as high pattern density, where almost all the design and implementation choices, especially the ones that affect the architecture, are guided and justified and motivated and documented in terms of patterns. And you'll see when we start talking later about pattern sequences and pattern languages that these patterns actually organize themselves in orderly ways that can give rise to solutions that are much more broad and much more pervasive than you could manage to do with just individual patterns in isolation. So to summarize the third and final part of this module, patterns support variation-oriented design, where you can figure out what elements of your design can vary. You can identify the applicable patterns. You can vary the patterns and evaluate the trade-offs. And you repeat this, of course, as you get more experience and as you work to other parts of your code. Oftentimes, you would repeat and apply these things hierarchically through different parts, either from a top-down or a bottom-up or a middle-out sort of way. And it's also important to realize that we don't want to brand everything as a pattern. Don't look at the world through pattern-tinted glasses alone. I've been on many projects where people would become pattern happy, and they would say things like, let's go invent some patterns today. What they really meant, of course, is let's go write some software. And if they thought carefully about what they meant, they really meant, as we write that software, let's try to apply the patterns that we know to that software to make it more effective, to make it more reusable, to make it more extensible, and so on. And what you'll discover is that many things are just designs. They're just algorithms. They're not patterns. It makes little or no sense to talk about the quicksort pattern or the heap sort pattern. It might make sense to talk about divide and conquer sorting algorithms as a pattern versus comparison and exchange sorting algorithms as a pattern. Those might be patterns, algorithmic design patterns. But the patterns, the algorithms themselves are rarely patterns. And design is sometimes just design. This is why it's so important when you start working with patterns and trying to write them down to be able to follow the rule of three, to be able to identify 3 different existing examples, especially if it comes from code other than your own. And it also helps to be able to identify human known uses for the patterns, because oftentimes that'll help you see how these patterns are recurring in more things than just the virtual world of software, but also can be applied to make a real difference in our everyday lives. So that wraps up this particular module, and we'll move on to the next one shortly.